Hey guys, how are you? This is again the network lectures. Today we are going to discuss the transient analysis, and it is the most important section of the network theory for GATE or ESE point of view. So before starting the transient analysis, we have to know some points. The topic 1 under this category, that is known as order of circuit. What is the meaning of order of circuit? What is the order of circuit? It represents the number of non-separable energy storing elements, L or C, present in the network. It represents that how many energy storing elements are present in the network that cannot be separated. So if I say this is a network, plus minus V, this is R, this is C, how many storing elements are there? There is only single storing element is there, so order is equal to 1, that is 1. Similarly, next circuit is, if it is plus minus some volt V, that is R, this is C, this one is also C, C1 and C2 are connected in parallel. We can make its equivalent, we can separate it by making some equivalent C1 and C2. So this circuit will reduce like this is R, this is single C, and this will be C1 plus C2. So its order is how much? There is only equivalent one capacitor is there, so order will be 1. So order will be 1. Similarly, we can perform number of circuits by doing like this. If I'm asking, this is third one, there is a resistance, this is resistance, voltage source V2, this is V1. Is there any storing element is there in the circuit? There is no storing element, hence the order will be 0. Similarly, fourth one, if this is the circuit, okay, see L1, L2. Can you make any combination between L1 and L2? No, we cannot make any combination between L1 and L2 due to the presence of this resistance. So how many storing elements are there? This is 1, this is 2. Then what is the order? Order is equal to, it's 2, as we cannot separate L1 and L2 by its equivalent. So whenever the question is asked in transient analysis, first of all check the order of the circuit, because maximum problems will be based on the first order circuit, and whatever today I am going to discuss, that is based on the first order circuits. If the number of order increases, then what we will do, perform some different analysis, and we will discuss all those things in the upcoming lectures. Now the next point is what? The equivalent circuits of what? Inductor and capacitor. See, I have already told you that for L, the general expression for the voltage is, for L, the general expression for the current is, that is ILT is equal to ILT0 plus 1 by L T0 to T VLT dt. This is the current expressions, and two currents are getting added. That means these two can be represented by a parallel circuit. Is it okay? This current represents the initial current, and this current represents for the current that is greater than T is equal to T0. So if I make its equivalent for L, what will happen? There is a current source. This is what? ILT naught, and this is what? This is inductor across which some current is flowing. This is ILT. What is the total current flowing in the inductor? That is equal to ILT. This current is represented by this current, and this current is represented by this current. This is the time domain equivalent circuit of a inductor. Similarly, if I want to do some more analysis for capacitor, then what we can say? We can say that in a capacitor, see, the general expression for the voltage is VCT is equal to VC T naught plus 1 by C ICT dt T naught to T. It is exactly same as what? That is in case of inductor. So is this is the voltage expression, and two voltages are getting add up. That means it is a series connection. So what we will do, we can represent a capacitor like a voltage source, and there is a capacitor. What this voltage source will represent, that is the initial voltage VT naught, and this is the whole voltage is represented at, that is equal to VCT. So in this one is representing this one, this voltage is represented by this one, and the total voltage across the capacitor is represented by VCT. Don't get confused if some initial conditions are given and it is asking about the capacitor voltage. Don't just calculate this voltage. No, it's wrong. Always calculate, because this is the equivalent of the capacitor, including its initial conditions. Is it okay? So if I want to draw the Laplace domain circuit model of each element R, L, C, then what will happen? So Laplace domain model for each element. So I'm talking about first one is resistor. So what is the resistor? This is resistor. There is a supply V of t, current is flowing IT, this is R, this is its time domain equivalent. Its Laplace domain will become, this is what? This is resistor, this is R, this will be in Laplace domain IS, this will be in Laplace domain, that is equal to VS. The next one is capacitor. If I'm asking about the capacitor, what will happen? The time domain model is what? This is the time domain model. C VC T naught. This is plus minus what? VCT. Now see, its Laplace domain equivalent. What will be Laplace domain equivalent? That is equal to voltage source, capacitor. This is represented in Laplace domain 1 by SC. This is what? This is the constant voltage. It is the initial voltage. It will be fixed value. That is 4 volt, 6 volt, 10 volt, or whatever it is. Okay. So if it is a constant voltage, then it's a function of unit step. That we can say that this is VC T naught divided by what? S. Laplace domain of unit step function is what? Step function is what? That is A by S. Okay. And this one is what? That is VCS, and the current flowing in the inductor, that is equal to ICS. This is the Laplace domain equivalent circuit representing as a voltage equivalent. Okay. Now we know that this is the voltage equivalent, and a practical voltage source can be converted into its equivalent practical current source. So by using source transformation, this circuit can also be represented like this. This is a voltage, so we can convert it into current source like this, and the capacitor will be here. What is this value? 1 by SC. What is this value? This value will become voltage divided by impedance, voltage this one divided by 1 by SC. If I will do what I will get, that is C into VC T naught, and this one is what? This is VCS. Is it okay? This is the equivalent current equivalent model in case in Laplace domain. This is equivalent voltage model in Laplace domain. Similarly, next one is what? That is inductor. Inductor model is what? In time domain it is like this L. This is IL T naught. This one is L. This is VLT. This one is ILT. Then its Laplace domain model. One is what? Exactly same procedure will be done. L is represented as SL, and this is constant current. This will be represented at ILT naught divided by what? S. This one is what? This is ILS, and this one is what? VLS. Is it okay? Now this is what? This is a current equivalent. We can convert it into its voltage equivalent. What I will get by using source transformation, what I will get? This is a voltage source. There is a impedance. This is SL. This is downward arrow direction. This will be positive. This will be negative. As this multiplied by this, if I will do, then I will get ILT naught into what? L, and this is what? ILS, and this one is what? VLS. So these are what? These are the equivalent circuit models. These are the equivalent circuit models in what? Laplace domain. Okay, so moving to the next topic, that is very important. That is very important. So I'm going to discuss. I'm writing it like what? This is important conclusions. Important conclusions. Now we will see that which type of, how many types of responses can be there in a RC, RL or RLC circuits. Is it okay? Okay, fine. See, I'm taking an example. Let's see a system that have input-output relations is given like a second order differential equation. It's like d square yt divided by dt square plus 5 dyt by dt plus 6yt is equal to dxt divided by dt plus 6x of t. This is a time domain differential equation relating input-output relations of a system, where xt is what? That is input, and yt is what? Output signal. Assume the initial conditions has been given like y of 0 minus is equal to 1, y of dash 0 minus is equal to 2. Then it is asking obtain the response of the system. Obtain yt is question mark if x of t is equal to what? U of t, unit step function. Then see, I'm not doing here, this question is not taken to solve it. We have taken this problem to understand different things occurring in a transient analysis. Okay, so if I'm going for solution, as it is a differential equation, the solution must be done in Laplace domain to get a easy things. Okay, so I'm just taking the Laplace transform of this equation. What I will get? D square by dt square, that means s square. What I will get? Laplace transform s square ys. Next one, minus s of y0 minus next one minus y dash of 0 minus. Similarly, this Laplace transform, this will be plus 5 s of ys minus y of 0 minus. Next one is what? This is plus 6 of ys, is it okay, is equal to s of x minus x of 0 minus, and finally plus 6x of s. This is the Laplace transform of the signal. Now it is given that x of t is equal to u of t, and u of t is defined as 1 for t greater than 0 and 0 for t what, less than 0, and the Laplace of u of t is what, that is 1 by s. Is it okay? And as t is less than 0, then this xt will be u of t and that will be 0. Hence we can say that x of 0 minus initial value of input signal will be 0. Is it okay? Now see here, just rearranging this expression, what I will get, s square plus 5s plus 6, that is y of s, is it okay, is equal to xs s plus 6 plus sy0 minus plus y dash 0 minus plus 5y0 minus, is it okay, and x0 minus is what, that is equal to 0. If I will make some more arrangement, can I write this expression y of s can be written as s plus 6 divided by s plus 2 s plus 3, this is x of s plus what, sy of 0 minus plus y dash 0 minus plus 5y0 minus divided by s plus 2 and s plus 3. What is this? What is this? If I see here, if you see here, you are getting two things. You are getting two things. First one is what? This response is known as forced response. This section has different names. This response is due to only x of s. This response is what? In this section we have only initial conditions 0 minus 0 minus and 0 minus. That means this response is only due to what? Initial conditions. If the response is only due to the input signal, then that is known as what? Forced response. If the response is only due to the initial conditions, that is known as natural response. Is it okay? If the response is only due to the input signal, this is also known as zero state response. If the response is only due to the initial condition, this is also known as zero input response. Is it okay? These are the some names for these responses. So whenever the response is only due to the input or supply, that is known as forced response or zero state response, or response due to only input apply. Similarly, if the response is only due to the initial conditions, this is known as natural response or zero input response, and somewhere it is also known as source free response. This is also known as source free response. Source free response. So we can say that whatever response we will get y of t, that will be the summation of natural response and forced response. So moving forward, we know that x of x is equal to what? 1 by s. Put this value and put the values of y0 minus, y dash 0 minus and y0 minus. What I will get, see here what I am getting. This will be is equal to y of s plus 6 by s plus 2 s plus 3 plus s plus 2 plus 5 divided by s plus 2 s plus 3. Now making its partial fraction, I will get 1 by s minus plus 1 by s plus 3 minus 2 by s plus 2 plus 5 by s plus 2 minus 4 by s plus 3. Is it okay? Now taking the Laplace inverse, what I will get? That is equal to y of t is equal to 1 minus e to the power minus 2t, 1 minus e to the power minus 2t plus e to the power minus 3t. Is it okay? That is u of t. Similarly, here I will get 5 e to the power minus 2t minus 4 e to the power minus 3t. Is it okay? So what is this one? This will give you forced response. This will give you what? Natural response. Is it okay? This is forced one, this is what? Natural response. So we can rearrange it again. Y of t can be written as 1 plus 3 e to the power minus 2t minus 3 e to the power minus 3t, that is u of t, and this will be the combination of y f of t plus y n of t. Is it okay? Y of t can also be written as 3 e to the power minus 2t minus 3 e to the power minus 3t plus 1. This is what? This is known as transient response. This is known as steady state response. This is also known as temporary response. This is also known as permanent response. Is it okay? So from the above discussion, if I conclude the above discussion, what will happen? First one, what I will say, that there are basically 4 type of responses are there. One is natural, second one is what? Forced response, third one is what? Transient response, and fourth one is what? Steady state response. Now listen very carefully. First one is natural response. See in this equation what you have got. Natural response is always contributed by the initial conditions only. Natural response is always contributed by the initial conditions always. That means it is entirely independent of the external applied input, and it is always temporary in nature. It is always temporary in nature. You can see here, what is the part of natural response? This one. You can see if t is infinite, what will become? It will become 0. That means it will die out after some time. So natural response is always temporary, and it is only due to the initial conditions and independent of the external applied input. First one. Similarly, second one, that is known as forced response. It is contributed only by what? External input. We have seen already. That means it is purely independent of initial conditions. Is it okay? So forced response is always due to the input or external supply, and it is entirely independent of the initial conditions. You can see here, what is this one? This is forced response. It can be a temporary. This section is temporary. This section is what? Permanent. So it comprises of both temporary and permanent response. Is it okay? But natural response is what? That is always a temporary response. Now third one, that is known as transient response. What is the meaning of transient? Transient means if we put the value of t, that is infinite, it will die out. So the transient means if we put t is equal to infinite in the above expression, which is going to be 0, that is known as what? The part of transient response. So transient response is always temporary response. First thing. Next point, who is going to contribute for transient response? We have always natural and forced. You can see from here, transient response means all the e to the power term will come in transient response. That means it is a part of forced response also, and it is a part of natural response also. So we will say that a transient response is contributed entirely by the natural response and some part of forced response. Is it okay? So it is always contributed by entirely by the natural response and some part of the forced response, or the entire part of the forced response. Is it okay? Now the fourth point is that is steady state response. You can see here, it is always the permanent part of the total response. This is the permanent part, that is one is permanent part. If we put t is equal to infinite in this expression, we will get always 1 here. This is the permanent response of the system, and it is contributed by the part of what? Forced response, and never be the part of from what? Natural response. So steady state response is always calculated or can be get from what? From forced response. It can never be get from a natural response. Is it okay? So whenever it has been asked about which type of response you have to produce, then always remember that there are 4 types of response: natural response, forced response, transient response, and steady state response. Natural is always temporary response, always contributed by only initial conditions. Forced response have both things, temporary and what? Permanent thing, and it is always contributed by only the external input. Transient response is always temporary in nature. That means if you go on infinite position, that response must die out, and it is always contributed by entirely by the natural response and some part of the what? Forced response. And a steady state response is what? It is always permanent in nature, and it is always contributed by only the forced response but never by the natural response, because natural response is always produces transient. Is it okay? So I guess in this lecture you have got a clear idea how to get responses and how to get the equivalent circuits of a RLC in Laplace domain. In next lecture we will discuss step response of first order RC circuit. Is it okay? So thank you very much, and for regular sessions on network theory, just log in to www.gatenoproblem.wordpress.com. You will get all the sessions we have conducted at and share this lecture also, and subscribe yourself to this channel. Thank you very much.